Hello, we're from Källingen Skola on Lidingö in Stockholm.
And we're 15 years old. We represent Sweden, and this is our calculation.
A new TV. Before the digital era, the Durant family owned a 32-inch TV in 4:3 format. The son says, we should buy a digital 32-inch TV in 16:9 format. It will take up as much room as the old one, and we won't have to change the TV stand. What do you think? First item of information, the family's TV and the TV stand. Second item of information, 32-inch is the length of the screen's diagonal. 1 inch is 2.54 centimeters long.
Third item of information, the format of the picture on the TV. 16:9 format is a ratio which designates the proportion of some pictures. It defines a picture's width that is 16:9 bigger than the picture's height. With 16:9 TV screens, the pictures are large. They are more adapted to our vision than the 4:3 pictures. This ratio enables to limit the reframing and also avoids black rows on each side of the pictures when they are displayed in an older format.
So basically, what we're gonna try and solve is whether the new TV will fit in the old TV stand.
First, we calculate the old TV's width and length. We know that they're 4:3 relative to each other. We also know that the diagonal is 32 inches long. To calculate width and length, we use variables. By using Pythagoras' theorem, we see the information that 3x in parentheses squared multiplied by 4x in parentheses squared equals 32 squared.
To simplify the equation, we remove the parentheses. So we get the numbers 9x squared plus 16x squared, which equals 32 squared. By doing simple maths, we know that 9x squared plus 16x squared equals 25x squared. Now we need to know what x squared is. And to get what x squared is, we divide by 25. So we take 25x squared divided by 25, and as this is an equation, we have to do the same on the other side. So we take 32 squared divided by 25.
So now we know that x squared is the same thing as 32 squared divided by 25. So to calculate what x is, we take the square root out of 32 squared divided by 25, which is approximately 6.4. We now know that 3x is the same thing as 6.4 times 3, which equals 19.2 inches. And we also know that 4x equals 6.4 times 4, which equals 25.6 inches. So here we have a drawing of the length and the width of the old TV, and as you can see, they say 19.2 inches, which is one of the sides of the old TV, and 25.6 inches, and its diagonal is of course 32 inches.
So now we're going to calculate the width and length of the new TV. So we do basically the same thing with variables and format. So we take 16x in parentheses squared plus 9x in parentheses squared, which equals 32 squared. We simplify by removing the parentheses again. So we have 256x squared plus 81x squared, which also equals 32 squared. By adding 256x squared plus 81x squared, we get 337x squared. And to find out what x squared is, we take 337x squared divided by 337, and we also have to do the same thing on the other side of the equation, and so we take 32 squared divided by 337. To then get what x is, we take the square root out of 32 squared divided by 337.
By taking the square root out of 32 squared divided by 337, we receive the information that x equals approximately 1.7. We then multiply 16 times 1.7, which is the value of x, which equals 27.2 inches. And we do the same thing with 9, so 9 times 1.7, which equals 15.3 inches. So we now basically have the width and the length of both the new TV and the older TV. And the question was whether or not the new TV would fit into the older TV's stand. And judging from these numbers, it clearly would not, because the older TV's width was 25.6 inches, and the newer TV's width was approximately 27.2 inches, which therefore means that the newer TV would not fit into the older TV stand.